Hello everybody, I just thought you might be interested in this. I've just been passed this thing by a member of my family who's bought it as a kit form from Ukraine. And it's a kit that comes in all the parts, the PCBs and everything else, and you just reassemble it yourself according to the instructions. And the kit seems quite good. There was a couple of ambiguous bits in there. The reason it was passed to me was that loading the firmware to make the processor run is quite tricky. Well, I thought it was because I hadn't used the Arduino setup before. I've used stuff like Atmel AVR Studio, which I know quite well. We'll talk about that later anyway. If you get stuck with your code, I couldn't find any help anywhere, so I spent a couple of hours figuring it out actually. So if you get stuck, let me know. But yeah, so here it is. It's a NIXIE clock using the old NIXIE tubes. You can see you've got 6 tubes and then 4 neons, which flashes the digits. And underneath each, they've married the technology of the old and the new. You've got the old NIXIE tubes, which were invented in about 1955 by somebody. Was it the Burroughs, I think, in America? Yeah, Burroughs, in about 1955. And it's just a multi electrode neon tube, really. You've just got one electrode. They work about 180 volts. Strike up one of the segments by reducing a low voltage on it, pulling down an open collector type high voltage transistor through a resistor. It then strikes up and then it drops to about 160 volts. So there's about a 20 volt drop once it's struck. So it's actually quite conductive once it's struck. It's doing the date now. I haven't set this up. I've only just really got it working about 10 minutes ago. So, and anyway, you can tell, I think the only people that make these tubes these days are the Ruskies, the Russians. And you can tell a Russian tube because look, if a 2 comes up, there's a 2, and then a 5. Look at the 5 on the end. The 5 is an upside down 2, which is peculiar to Russian tubes. Have another look. You can see there's a 2, 3, 4. You can see the 5 coming. It's an upside down 2. But they come in all sorts. You can get round ones, so you look end on. And the number of digits, normally 0 to 9, obviously. And they arrange the orders of the digits to be in a sequence from front to back to make the wires, the electrodes inside. We'll have a close look at one in a minute. You've probably seen these before. Less likely to obscure the digits. So I think we've got something like 0 at the back and 8 at the front because it's got more wires in it, 7 slightly back. Anyway, they arranged it in theory to allow the other digits not to obscure each other, the minimum amount of obscuring going on. But you can see it's quite cool. They move backwards and forwards, and then you've got this LED. It does all sorts of things because the software that drives it, I'll show you in a moment, is from AVR microcontroller with flash and E² and RAM on it. It's a very powerful RISC processor, and they've been adopted by the Arduino project, I think, and are used widely by a lot of hobby people. So what we've got in here is the ability. I've got the source code for this. I've just compiled it and I've just downloaded it, so I can change anything I want on this board. And on here we've got temperature sensing. There's also a GPS module as well, which I'm guessing would just be for GPS time synchronization. And then there's fireworks and all sorts. You can see this is the general. It's quite dark in here at the moment. And I've just done it so you can see what's happening, in terms of the features on it. I mean, it's quite good. If I just unplug it and plug it back in, take the power off, stick it back on again, and you get this startup sequence, which again is quite entertaining. Nice to see after you've been working on it, actually working. And of course, it has to go and play you a tune. There you go, now it's running. So there she is. What do you think? It's quite a thing. Yeah. So one thing I was quite surprised actually for a clock, it's actually producing quite a lot of light, and it's quite nice because it's got a real-time clock which is battery backed in the design, so that if you want to, you can use it like a small feature light in your room, and you just turn the power off. And then when you turn it back on, you can suppress that tune in the firmware if you want to. Turn it back on. it'll come on. So you can kind of use it like a light as well. You don't have to have it switched on all the time. It will keep time when you turn it off. So there's that as well. But what is quite surprising, because you've got 12-volt input up this end. Up here, up this end, you've got the 12-volt input. And yeah, it does take about 7 watts of electricity. Obviously, the 12 volts going in, you've got to generate the 180 volts or so for the electrodes. They're taking about 180 volts, about 1 milliamp each, I think, at the moment. But you can do the math on the power. But there is just a simple flyback converter down here, flyback step-up converter, which is just a switching circuit, a controller, and a big coil, a diode, and it just pings the 12 volts up through overshoot or flyback up to 180 or 200 volts offload. So anyway, that's you've seen the features of it. It does loads of things. I don't know whether if I press any of these buttons will it do anything interesting. Did that colour change or something? I don't know. What was at the time? Anyway, you can set it up in the software to do time, date, temperature, and so on. 3rd of the 1st, 00. I don't know what that is. Is that the date? I haven't set this up. You can gather I haven't set this up. Oh, is that a timer? Oh, I see. I'm going through the programming section. But you get the idea. Should I just turn the lights on so you can see what's going on now? So here it is. I'm a bit wary of this because it's got 250 volts on parts of it, 240 volts on parts of it. And there you can see it. These are just little tubes you put on top of ordinary indicator LEDs, like the not LEDs, neons like you find in a plug or behind a main, a switch socket, just an ordinary mains indicator neons behind little glass sample test tubes. And the tubes are soldered straight into the board, these Russian tubes. And this is available as a kit, and it's an open source kit. Just unplug it, then I feel a bit more relaxed. There you go. So it's an open source thing, so it's on. It's online, so all the schematics, all the circuit diagrams, all the software, the source code, everything is available to anybody that wants to use it. Actually, it's quite warm up this end. Quite warm down there, so there's a little bit of warmth there. So it comes with instructions and a checklist for all the parts. And this bit on the bottom here, this is the Arduino board for those of you not familiar with Arduinos. It's got something like 3 UARTs for serial communications on this micro. It's got I2C, it's got SPI bus, it's got analog inputs. The only thing it hasn't got is voltage outputs, i.e. D to A. It's got A to D's built in. Mega 2560, that's what it is. And you can see all the ports. You can do all sorts. PWM modulation, motor drive, very, very flexible. And in the Arduino system, you just plug the USB jack into your computer. It loads the drivers, and then you can use the Arduino development system, which is called something weird. It's just called Arduino, and in there you've got a window. You can write code, you can compile it. It's written in C mostly, and there you go. So let's have a quick look at the board and we'll see what's on there. So this is the electronics we've got. Should I turn it up the other way? Probably will. There. So there's the GPS. There's an I2C bus that goes out to the GPS module, so you can just it's just an Arduino GPS module, and it's connected to the processor up the top by serial connection. So high-speed serial bus, basically, a couple of wires. And then we've got the 250 volt capacitor, we've got the power supply, the power supply chip, and the step up from 12 to about 190 volts here, this section here. These are the driver chips, and they're serial clock data in, so you clock a series of noughts and ones in, and there's a clock in and clock out. I think there's 2 separate data lines on this, so you can daisy chain these down and have the data clocking through, setting up the registers of noughts and ones in here, and then if you get a 1, then when you enable the output, basically that one filament goes on. Obviously in this case, this is driving 2 digits plus the decimal points as well, I think, or the colons, the flashing colons, and so it also could be driving one of those multi-segments. You can get these NIXIEs with 8 or 10 segments that do alphanumeric as well. But one driver chip, there's the other driver chip down this end. I need to clean it because I had to clean up some of the solder joints on it. The clock, the sounder, and you can see there's quite a comprehensive legend, but there's not that many components. You've got an infrared receiver, so you can turn it off and on and set it by infrared. So it's quite feature rich, really. And then the test points and stuff like that. And what was wrong with this one was there was a 3-digit temperature sensor there, which hasn't got the legend on it, which way around it was, and it was in the wrong way around. So it's a serial data temperature sensor. It's here somewhere. Yeah, this little thing. And they're about £4 each, actually. It's a Dallas chip. And yeah, you've got 5 volts, 0 volts, and just I2C data. So it's a integrated temperature sensor, digital temperature sensor. You can just read it out with your microprocessor, direct from temperature to data, which I thought was quite neat, actually. So I'm glad I came across that, because I might be able to use it at some point. I don't know. What have we got? We've got a pot here, I think, for setting the brightness. You can adjust the brightness of the NIXIEs by twiddling that multi-turn pot. But you get the gist of it, really. There it is. It's quite a simple assembly project. And then these headers here are all where the Arduino board plugs on. I think this 2560 is quite a powerful chip. You can buy a cheaper board than this one with a smaller processor on. But these are about 12 or 13 pounds on Amazon. And the chips themselves are £3 or £4. So quite a good deal, really. And you've got USB interface and everything on there, and power conversion. So yeah, you plug it onto these headers there, and away she goes. Plays your tunes and everything. So that's the hardware. Not bad. It was, the kit I think was about 140 quid, including the tubes, or probably 60 or 70 quid without the tubes. But you can see generally what's what. Let's have a look at the tubes under the macro station, shall we? There, I think you can see pretty clearly in there the actual all the different electrodes and the different shapes, how it works. You can see the screen on the front, which is the anode, and the fluorescent cathodes fluorescent anodes actually are all cathodes, fluorescent cathodes. It's just basically a neon tube with multiple electrodes in different shapes. You can see. One thing I should say about this, I mean, you can see it doesn't look very clear at the moment, but most of these clocks and things, and like the old weighing scales, had a dark red stroke orange filter in front. And when you put a colour filter, it only allows that light to pass. They really do stand out. They are quite good bright displays. They were used widely in the 50s for all sorts of test equipment and clocks and weighing scales and computers as well. There was even a digital version with multiple electrodes in a magnetic field, and you could use it to store information like a memory bit. You pulsed it and it would move on to the next digit, so you could use them as things like counters. And so rudimentary computers and things were based on them. I think they were called what were they called? I think they were called trochotrons. Yeah, trochotrons I think they were called. And yeah, they were kind of like a rudimentary computer where you had multiple electrodes, as I say, and then every time you pulsed it, it moved on, it struck up with the next one and stayed on, so it would store that bit of information and also count up a digit. I suppose it could be some of the trochotrons just had dots all around, and you had a scale printed on the outside of the tube. It was a round-facing tube, and you had just electrode pins, which you can see it count round, so you could read off, if you were counting pulses, they would count automatically with no electronics almost, and then you could see what the result was at the end. It's very, very interesting. Didn't last long, but it was fun at the day. And I think NIXIE stands for numerical indicator experimental number 1. NIXIE. If that's true. Numerical indicator experimental number 1, and it's stuck as a name for this technology. Alright, so that's the clock anyway. You've seen it, and it's quite easy to put together. A nice project. nicely soldered by a person who had no soldering experience did this. Can you believe it? Very good. I was quite amazed at the actual soldering quality that had been done. Obviously got a very good eye. It was a young 20 or 25-year-old chap that did it. Yeah, so well done. And it's working, so you can come and get it now. And I'll just switch over and just show you the software environment, just in case you want to be interested, or you are interested in building one of these things. I'll just show you briefly the actual how you program it. Yeah, so here's the programming environment. It's called the Arduino, what's it called? It's just called Arduino actually. And it is a C compiler. So you've got source codes and all sorts of library files and things like that. You can see them lined out across here. Now, when I loaded the software the first time, I hadn't used the Arduino environment at all, and it's kind of a dumbed down version of a proper development environment, but it's pretty good actually. But like everything else that's free, it's a bit difficult, and I think a lot of people that do know how to use it know exactly what they're doing. And let's face it, you know, if they just spent an hour or half an hour writing it all down on a sheet of A4, it'd probably make it a lot easier for all of us. But I couldn't get it to compile, and I'm used to, there's some library files. On this thing, there's the main software in a directory structure, and you choose out the firmware. And it's also got a hex file, which is compiled output from the compiler. So the compiler will take all this code, all the inclusions of the libraries that you've specified, and anything else, and compile it all into one hex machine code file to run on the processor. It's just a whole string of hex digits. And normally when you program the processor, you can do it via the USB, via a thing called a bootloader, which is a piece of code that runs in the processor and will take the code from the bootloader via USB. So it's a program you communicate with, and then it in turn receives your data, your program, and writes the data locally to flash using the micro itself to write its own memory. So that's what a bootloader is, and that's what you normally use when you download the code via a USB interface. If you are actually hard coding the processor, you're actually jumping onto it in hardware and taking control of it. There's two ways. There's a serial wire programming, which is just a single wire. It's a two-way bus, and it's called ISP, and I think it was pioneered by Atmel. And so on these tiny processors that have only got 3 or 4 pins, you can take over the processor and actually program it just using one pin and a serial string of noughts and ones down it and communicate. And even better still, you can actually step through the program and debug the actual C program running on your tiny little processor. I've done that many times. It's quite good fun actually. And you can see all the ports and all the internal... That's the dog, it's just getting tangled up in the wires. Are you comfortable now? Yeah, you can see all the ports and all the different registers in your process. You can stop it, you can set breakpoints, you can examine the value of registers. So you can get right down there just by this one wire, the serial programming wire. Very ingenious and works well. And then there's the JTAG interface, which was intended initially for test purposes to enable you to take over a processor or a chip from within and do a kind of diagnostic. You can imagine if you've got loads of logic chips all connected together, if you can take over all the pins by the JTAG interface, you can actually do a kind of continuity check for shorts and opens and make sure you're connected to other chips. But also that can be used for programming. And on these boards, I'll just show you one if I can find one. Here's a spare one which I blew up earlier. There's a little header here, look. This little header here is the programming header. So onto that header you can plug a number of different programming tools. Obviously between the Arduino here and this has to be a piece of hardware which you can write to it with, and you can get all sorts of little USB programmers. You can get, well, I've got an example here on the bench actually. This is an AVR, USB AVR programmer. So your USB goes in there, goes off to the drivers interface to the AVR program, and this is the header which you plug onto the board the right way around. Plug it wrong the way around, it will blow the chip up. I know that, trust me, from experience. So So make sure you get pin 1 up the right end. On this one, pin 1 goes the same as the... Oh, it's not even marked pin 1 on there, but make sure, look in the documentation and see which way around it plugs on. So that's a simple programmer. They're about £4 or $4 or something. And then you've got the Atmel JTAG ICE programmers, which again are very good. And there's their adapter cable is not the same as this adapter. This is an adapter, this part here, which adapts from the 10 pins down to the 6-pin header. But this adapter is just this adapter here. This thing is not the same as the adapter for the other programmers, because they all different pinouts. It will plug in, but it will blow your chip up again. So that's the adapter with the Atmel JTAG ICE. So you've got USB serial power on these. Anyway, there's a whole number of programmers for this software, and if you look in here, you can see the programmers in this list. You can see that list there, and there is a hex file. If we go in, in the directory, there is this. Will if I compile now, I'll just compile this and see if it works. You can see this thing going over here, it's counting over as it's doing the compilation. It won't download it because there's no programmer present, or it will say it cannot find target because the actual Arduino board is not connected to the programmer, the programming hardware. There you see, so receive timeout. Alright, but they do, unfortunately, they do give you a hex file which is a compiled step, which means you don't need to get the compiler environment working. But the trouble is with that is that when you download it with the standard, you take the hex file. Normally you would take a hex file and you would just download it into the processor and it would run. But that's not the case with Arduino, because I've downloaded this hex file which they supply, which was said was compatible with this hardware, with 3 different hardware programmers, including the AVR programmer and the AVR dude and the STK 500 development kit which I've got, and none of them would make the actual code run. The only way I could make the code run was to fiddle about and fart about with this development environment and make it so it would actually compile. It was coming up with pages of errors and make it compile. And for some reason I uninstalled everything, installed everything again, and it went a lot better. There was something weird about this environment that got into its knickers in a twist, basically. But the one thing you must remember to do is to copy the libraries which are supplied as in the subdirectory here. You've got libraries, and you need to copy those libraries across into the path where this program is called from. There's a library directory, and you need to copy them down there. And there's 1 or 2 files as well which you need to look up. So if it won't compile, you've got to look at your libraries. And if you want any help on the libraries, give me a shout. If anyone's interested, I'll do a thing on the libraries, a separate thing on the libraries. But the environment's fine. But now look, we've got this now. We've got this code, and then we can go through this code and we can change anything we want. So if you a little bit of expensive, experimental program, you want to change it plays the Pink Panther, you can change the tune. You can change anything. You've just got to read the code and then decide what you want to do with it. There's something particularly annoying about the way it starts up. You could change that too. So it's quite well written and quite readable. So yeah, I think if your hardware would be easy to do, the programming, unless you've done it before, you could spend a while. If you're familiar with the Arduino system and the way that the programmer works and the compiler, you'll be okay. But the main thing is, if you download the open source software for this and you don't have one of their named programmers to put the hex code in directly from their compiled hex file, then you're going to have to make it compile. And to make it compile, you've got to get the libraries right. And to get the libraries right, you've got to copy those libraries they supply over into the Arduino System32 Arduino working directory, where the NIXIE file that runs this utility is located. All right. If you got stuck, give me a shout and I'll give you some more information. I don't think, unless someone's any interested in doing it, I can't be bothered to go through it right now. But yeah, that's the old clock. I hope you like that, found it interesting, not too boring, but yeah, it's a nice thing. It's a bit of it's a feature in a room, put it that way. It looks good. So yeah, I'll see you soon.